So up until now, I've been talking about some compounds, some elements, some mixtures. So we want to know how to name these compounds. I mean, that's an important thing to do. So if we look at our periodic table, talked a little bit about this before. We talked about covalent and ionic. And so you need to have a periodic table sitting with you during this part. And it would be really helpful if you have one that you could write on. Okay? So you could pause your video and go get one. So the first thing you want to do with your periodic table, if it doesn't already have it, is you want to draw in your staircase. And this periodic table that I found from the internet did not have that in, so I draw it in. It goes right underneath boron, and then it just steps over. Okay? And so this staircase is what divides, essentially, our metals from our nonmetals. Elements that sit on the staircase are what's called our metalloids. Okay? Metalloids have metallic and non-metallic properties. For the course of this discussion, though, we're not going to worry about the metalloids. All we're going to focus on is where are our metals, and they're over here. Okay? Where are our nonmetals? They're up here. And all the nonmetals are up here except for our one exception, which is hydrogen. So don't forget, hydrogen is also a nonmetal. Okay? So you should have your periodic table. You should have your staircase drawn in. You should go ahead and label metals over here, nonmetals over here. Okay. First thing, we're going to break our types of compounds into 3 categories. And we have to split them into these 3 categories because naming and writing formula rules are different from each category. So before you can start to name or write formulas for something, you have to know, is it ionic, is it molecular, or is it an acid? So ionic substances are substances, compounds, where the atoms are ionically bonded. This happens when you have a metal plus a nonmetal, so below the staircase, above the staircase, or any substance that contains at least one polyatomic ion. So let's look at this word for a minute. Poly means many, atomic means atoms, and ion means charged particle. Examples of polyatomic ions that are common and that you should know are NO3 negative, which is nitrate, SO4 2 minus, which is sulfate, PO4 3 minus, which is phosphate. You can also have NO2 minus, nitrite, SO3 2 minus, which is sulfite, and so on and so on. There's lots and lots and lots of these polyatomic ions. The key here is if you see the word endings ite, I-T-E, or ate, A-T-E, you know that a polyatomic ion is present there. Okay, so you may want to do some review and look some of those up, and we'll talk about them as we go through the examples. Molecular, another name for that, those type of compounds or molecules is covalent. And these are substances that are covalently bonded. The atoms are covalently bonded. And these substances contain only nonmetals. Only nonmetals. Acids, for the course of our discussion, anytime we see H first, we're going to call that substance an acid. We're going to name it like an acid. For example, HCl. We would say, okay, that's an acid. Even though H is a nonmetal and chlorine is a nonmetal, we're not going to name it using the molecular rules. We're going to name it using the acid rules. Not all acids have hydrogen first, and not everything with hydrogen first would you name like an acid. Example, H2O, we would just call that water. So some things have common names that we use all the time. So this is a very simplistic definition here, but it's something that we need to use for just starting out. Okay, so you've got your periodic table sitting there. You should. Right now, what you need to do is kind of label some things. You want to label this first column with a +1. So what I like to tell my students to do is put a +1 up here at the top. And what that means is that when these elements form ions, they're going to lose one electron to form a positive ion. by losing one electron, these atoms will gain what's called a full valence shell. Okay, and that's why they lose just one. And we'll talk more about that later. This column I would put up at the top +2. And so what that means is that when these atoms form ions, they lose 2 electrons and they get a +2 charge. Over on the other side, on the nonmetal side, this first group here, this first column, is the noble gases. Notice there's no charge there. They're noble gases. They have full valence shells. They're not going to really react to form compounds. They definitely do not form ions. And so you can think of them as being like a 0 because they don't have a charge. They don't form ions. The next group over is going to gain 1 electron to become -1. Next group is going to gain 2 to be -2. Next group will gain 3 to be -3. Even though only certain elements are highlighted in this graphic, you can use this convention for everything on the column, okay? 3 other elements that I want to point out to you right now are aluminum. Aluminum is +3. I'll try to write it big so you can see it there. The next diagonal element is zinc, and it's +2 all the time. The next element diagonal is silver, and it's +1 all the time. So when these substances form ions, when they react to make a compound, these are the charges that they're going to have. Notice this section here, there's nothing labeled. It's because these are called transition metals. They can have all different kinds of oxidation states, and so we can't pin them down to only one charge. The reason for this is because we have these d electrons, which we'll talk about later, and so it's not a set convention of what happens with these elements, but we can use our formulas to figure out what the charges are. I'm going to show you how to do that. So right now you should have your periodic table written on. You should, just to kind of recap, you should have your staircase, nonmetals, metals, okay? You should have your charges, +1, +2, because these are metals, they're losing electrons. 0 for noble gases, -1, -2, -3, because these are nonmetals, they're going to gain electrons. And then +3 for aluminum, +2 for zinc, +1 for silver. So, we've been talking about ionic bonds, so what is it? I tried to draw this picture earlier, not very well, so I'm glad I have a picture here. Ionic bonds form between 2 ions. They have to be positively and negatively charged because we know opposites attract. So the bond is actually just an attraction between positive and negative ions. So if we look, this graphic is showing a neutral sodium atom. Neutral sodium has 1 outer electron, which is represented by this kind of larger shell here. So when that 1 outer electron is lost, you see here, okay, it forms a positive charge. Here we have 11 electrons, which are negative, 11 protons, which are positive. They're equal amounts, so it's neutral. Once we lose an electron, we have 11 positives and 10 negatives. You can do some mathematics there. 11 minus 10 is +1. So we get our positive charge. Notice when an electron is lost, the substance gets smaller because you're basically losing that outer shell there, represented by the purple circle sphere. Then for chlorine, what happens is this electron that's lost from the sodium is actually gained by the chlorine. Chlorine actually has 7 valence electrons, and atoms are really trying to get 8. And so by gaining this electron from sodium, chlorine can achieve its full valence shell. If you look at your math here, we have 17 positive protons in chlorine, 18 negative electrons. And so if we do our math, 17 minus 18, what does that give us? A -1 charge. Notice adding the electron. Electrons are repulsive with other electrons, right? Like charges repel. Because of that repulsion, that is going to spread out a little more from the neutral, and we get a little bit larger size. So that's kind of a lot of extra information there, and it's something that we'll talk about later on. But these all come together, they form this nice little crystal lattice, and ionic substances are very crystalline in nature, as you can see here. This is kind of a good example of particulate level, okay, and then macroscopic. You could actually kind of see that. How do we name these things? It's pretty simple to name ionic substances. What you're going to do is you're going to name the first element or ion. You're going to change the ending of the second element to IDE or IDE. If it's a polyatomic ion, you don't change the ending. Very important. And so if we look at this substance, first of all, we have to look up Mg, we have to look up Cl. We see Mg is a metal, we see Cl is a nonmetal, so we classify it as ionic, and that's how we can follow these rules, okay? So you got to classify first. We look up K, that's a metal. Then we see lots or two different atoms, right? That's our clue that this substance contains a polyatomic ion. And this is one of the common ones, NO3 negative, which is called nitrate. And so if we go to name these, we're going to say Mg. Okay, what is Mg? You should know it's magnesium. If not, hopefully you've got a periodic table there that gives you your names of your elements. So we just simply write magnesium. Then we see Cl. That's chlorine, right? But our naming rules say change the ending to ide. So instead of writing chlorine, we're going to write chloride. So you would name that magnesium chloride. Students always say, well, there's a 2 right there. Don't we have to say do something with the 2? The answer to that question is no, and we'll talk about why that is in just a minute. So for this substance, you would name K. That's potassium. Okay. And then NO3, notice if it's polyatomic, you don't change the ending. So this is just potassium nitrate. Okay, so naming ionic substances is pretty simple. You name the first, name the second, change the ending to ide. Unless it's polyatomic, you just write down what it is. Okay, so I've got a couple for you to try. You might want to write these down, pause your video, see how you do. So take a minute to pause it out. Okay, now that you've had a time to work on these, let's go through them. The first one's K2O. So you would name your K, which is potassium, and then your O, oxide. RB is rubidium. Cl will be chloride. Ca is calcium. S you would call sulfide, so not sulfur, but sulfide. And then in the last one, this is the hard example. Notice 1, 2, 3 different elements. That's your clue that a polyatomic ion is present, and the polyatomic ion is one I gave you at the beginning. PO4 3- is called phosphate. And so this substance, you would say aluminum phosphate. Okay, so hopefully you did well with those. If not, there's lots of online tutoring things that you can go to. Just type in practicing naming ionic substances. Lots of stuff comes up. Science Geek is a good website. He's got a thing where you can do multiple choice quizzes. All right. So remember we talked about transition metals and how they don't have a set charge? Since transition or set oxidation state, since they don't have a set charge, you have to write down what the charge is in your name. Okay, so you're going to name these as before, but you're going to write the charge of the metal in Roman numerals in parentheses. And so this is where it gets a little bit harder. Okay, so our first example we're going to do is this one. So we would name this like we did before. We would name Cu, which is copper. If you look up coppers, they're in the center of the periodic table, and those are your transition metals. And then we would name chloride. Okay, but since this is transition, we got to do something extra, because the person reading the name doesn't know how to write the formula because you don't know the charge unless you tell. So based on our formula, we can figure out what the charge is. Okay, so this is what you do. You got CuCl2. We don't know the charge of copper, but we do know the charge of chlorine, okay, or chloride. So if you look on your periodic table, you should see that each chloride is a -1 charge, okay? If you look at this formula, chlorine or chloride is -1. How many do we have? We have 2. And so what's my total negative charge? Hopefully you will see that my total negative charge is -2. Okay, I have 2, each at -1, so my total is -2. To form a compound, we must have a neutral substance. And so the copper has to be positive, number one, and it has to be positive what? So in other words, you ask yourself, what can I add to -2 to make it equal 0? And hopefully everybody knows, everybody can see +2. And so from our formula then we can tell that copper must have a +2 charge, so we write this as our name. And you would read this copper 2 chloride. Let's take a look at the next example. This was a little more complex. If you notice, there's more than one type of atom, right? And so that tells us one of those polyatomic ions is in there. So I'll list it out for you. CO3 has a -2 charge, and it's called carbonate. That's another really common one. Okay, a lot of you in labs will use baking soda, sodium hydrogen carbonate. So this is one of those you should definitely know. So Cr we would call chromium. CO3 we would name carbonate. Okay, and then we're going to do the same thing over here. We've got to figure out, based on our formula, what is chromium's charge, okay? So we look, here's our negative ion, this carbonate thing. What is the charge of carbonate? It's -2. And this is where students a lot of times get confused. You may not do this with your students, but a lot of students would say then, if I said, how many carbonates are there? A lot of students would say, there's 3, okay? That's not true. Carbonate is CO3. So if you look at this formula, how many CO3s do I have? I only have 1. And so I have 1 CO3, add a -2, so my total negative charge is just -2, which makes chromium +2, because it has to equal out to 0. Okay, let's try another one. So this is the most difficult example, saved it for last. All right, it's Mn, so that's manganese. O, we would call oxide. And then we got to figure out the charge of manganese. So we write our formula. We circle our element, or our polyatomic, in this case just an element. We look up our element's charge. Oxygen's charge is -2 if you look on your periodic table. Just like we did here, -1 times 2, okay? -2 times 2, because we have 2 oxygens. It's going to give me a total of -4. All right? So what charge does Mn have to be? It has to be +4 to equal out to 0. Okay? So the correct nomenclature name for MnO2 is manganese 4 oxide. But if you're looking at it, looking for this stuff in the chemical stockroom, or even looking it up in a chemical catalog, what you're going to see is the name manganese dioxide. Okay, so kind of more common name for this substance is kind of held on here. But technically in the rules you should name it like this. But you may see this also called manganese dioxide because of the 2 O's. But typically this di notation here is reserved for covalent substances. But this is a common name. Okay. So one other thing I want to talk about, like common name stuff. A lot of times in class you're going to use baking soda. The formula for baking soda is this. So we can call this baking soda. All right. We can call this sodium bicarbonate. Or we can call it sodium hydrogen carbonate. Okay, so they're all the same thing, which is why nomenclature sometimes is so confusing. And that's why we've kind of settled on this one convention for naming stuff. But still, we go off track and use the common names. So this is an ionic substance. It's Na+, and then this polyatomic ion here, HCO3 with a negative charge. This polyatomic ion has 2 names. You can call it bicarbonate, or you can call it hydrogen carbonate. Both are correct. So since this is a substance that a lot of times we use in science class because it's readily available, cheap and safe, I just wanted to kind of go through the different names that we have there and what kind of substance it is. And so now we've got a few more for you to try, and I've mixed them all together. So you've got some transition and some not transition. They are all ionic. As you'll see, metal, 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 metal. So if you see a metal, you know automatically that it's going to be ionic. So you might want to pause your camera and go ahead and work on these. Okay, now that you've had time to do it, Fe is a transition metal. The name of this would be iron 3 chloride. I'm just show you real quick how I got this. So it's FeCl3. So here's the negative ion, which we call an anion. This ion has a -1 charge. There's 3 of them, so my total is -3. I multiply those, right? And then for it to equal out to 0, my iron has to be +3. So that's how I get my Roman numeral 3 there. This one would be nickel 2 sulfate, magnesium oxide, no transition, so real easy, cobalt 2 bromide, cesium fluoride, no transition, and barium chromate, no transition there. So just to kind of go through the transitions real quick, because that's usually what people have trouble with. The nickel sulfate, this is our anion. Sulfate is charged as -2. So the nickel has to be +2 because there's 1 of each. With the COBr2 there, our anion is Br, bromine or bromide. It's a -1 charge. There's 2 of them, so -2. So cobalt must be +2 there. Here we have another polyatomic ion coming up. We know that because we see 1, 2, 3 different elements. This is chromate. Chromate has a -2 charge, barium +2. But we don't have to include that charge because barium is not a transition metal. So these are the names correctly given to you there. And so that is naming ionic substances.